What is rheology? So here rheology is the study of flow and deformation of matter. It describes how the material flows when force is applied and how it undergoes deformation. Here deformation means what? Deformation means here when any force is applied to a substance, so it undergoes some changes. So these changes may be stretch or compress or bend or twist, or it may be flow. So that is called as change in size or change in shape. So deformation means here deformation may happen due to change in size and change in shape. In simple words, we can say it is the science that deals with the flow behavior and deformation behavior of the substances when the force is applied. Here the rheology answers mainly two major questions. One is how does the material flow and how does the material deform, that is change in shape and change in size takes place when the force is applied. In the GPAT point of view, we can say rheology is not a property of the material, it is the study of properties of flow. Now, what is pharmaceutical importance of rheology? So rheology helps us to understand and to control the flow and deformation behavior of pharmaceutical products. It is essential to design certain dosage forms like suspensions, then like emulsions and some semi-solids and liquids and some injectables and even though some ophthalmic preparations. So here in the diagram we can see suspensions are there, emulsions, semi-solids, liquids, injectables and ophthalmic preparations. So it helps in the case of suspensions, it helps in controlling the sedimentation rate and improve the redispersibility and pourability. And in case of emulsions, it helps in to improve the stability by controlling the flow properties, and it also helps in uniform distribution of the solid matter in the liquid phase. And in case of semi-solids, it affects the spreadability, which is very important in case of semi-solids, and it also helps in maintaining the consistency, and it is very important for the patient acceptability also. And the next thing is in case of liquid formulations, it determines the pourability and ease of administration and influence the dose uniformity also. Then in case of injectables, it is important for injectability through syringes. Then in case of ophthalmic preparations, it increases the contact time on the eye. So these are some very important benefits or importance of the rheology in the field of pharmacy. Now what is force? So force is defined as it is a push or pull which is applied to a body which tends to move or deform it. Means force is nothing but a push or pull which is applied to a body, to move or to deform it. Means change in size as well as change in shape. So that is what force is: a pull or push which is applied to the body, which tends to move or deform it. So what is the SI unit here? The SI unit is Newton, CGS unit is Dyne. So what is the mathematical expression? F is equal to m into a. M is equal to mass of the body, that is kg, and a is equal to acceleration, that is meter per second square. Examples for this one is pushing a trolley, pulling a bow, and pushing a door. So force is a vector quantity and it has both magnitude as well as direction. Now what is the shear stress? So it is a tangential force applied per unit area on a body. So now what is the tangential force and what is shear stress? Suppose consider a flat surface, and on that flat surface a book is there, and we are applying shear stress to this book, and this book is moving in a forward direction, and here there is a table. Now the tangential force or shear stress means the force which is going to act, that is in a parallel direction to this table, that is in a parallel direction. The force is not in a downward movement, it is not in upward movement, but rather than it is a parallel movement or parallel direction to this table. So this is called as shear stress, and this one tangential force means here this moving plate and the force which is applied to this moving plate is parallel to this surface, means the plate is moving like this, and the force which is going to act on this plate is parallel to this surface, means the force is not in the upward direction, it is not in the downward direction, but it is in parallel direction to this surface. Now what is the mathematical expression for this? Here F is equal to F by A, small f by capital A, whereas F represents shear stress, that is Dyne per centimeter square, we can use the unit, and small f is equal to tangential force applied. It is measured by the unit used is Dyne or Newton. Then A is equal to area over the force is applied. So the area over the force is going to apply. So this is the fixed plate, that is represented as centimeter square or meter square. Now we are going to simplify this one. The shear stress is the tangential force, that is parallel force which we are going to apply per every unit area on a body. The units are CGS units, that is Dyne per centimeter square. SI unit is Pascal, that is Newton per meter square. So here the important point: shear stress always acts parallel, that is tangential to the surface, means always the shear stress act in a parallel direction. It is not in the downward and it is not in the upward, it is parallel to the surface. Now according to the GPAT point, shear stress is responsible for causing flow in fluid when the tangential force is applied. Means in the study of flow of fluids, for example, on a surface the liquid is moving, and it is moving in a parallel direction, and the force is applied is also in parallel direction. So that is what we can easily study the flow behavior of fluids. Rate of shear, G. Rate of shear is nothing but it is the rate of change of velocity, means speed with the distance between the two layers of the fluid. For example, consider here there is a fixed plate. Initially the velocity is 0. So as the time goes on, as the distance between, now the viscosity. So viscosity means what? So here the simple definition. Viscosity is nothing but it is a property of the fluid that is going to resist the flow. Means it will not easily accept the force. It will not easily accept the force and move. Rather than it will oppose the force and resist the flow. Why this is going to happen means it is due to internal friction between the layers of the fluid when they slide over another. Here we can see, suppose the liquid or the fluid layers, if they are more viscous in nature, if they are more viscous, what happens? Even the force is applied, these viscosity that is due to internal frictions, that will create opposite force to against that force, that will create a opposite force against to that force and will oppose us the flow or movement. Easily we can say, if the liquid is more viscous in nature, if it is more viscous in nature, then it will, the flow of the liquid is very slow. The best example is when you see the oil, it will flow very slowly, whereas when you see the water, it will flow in a faster rate as compared to the oil. Then what is the mathematical expression for this one? N is equal to F into G, whereas N is equal to viscosity, F is equal to shear stress, and G is equal to rate of shear. SI units we can use Pascal, then CGS unit Pios. Okay, what is the significance of studying this viscosity here? High viscosity, high resistance to flow. Low viscosity, low resistance to flow. It determines the ease with which the fluid flows. It is very important in the rheological properties. How? Now example, we can see the water moves very fast due to low viscosity. Then compared to water, oil has medium viscosity because it is more viscous than water. Then honey, it is even more viscous than oil. Then toothpaste, very high viscosity. So here viscosity measures the internal resistance offered by the fluid to flow.